In this video, I will be going over exam papers, some test papers about intermolecular forces and physical properties. Now pause. If you need the videos where I introduce this, I go over the theory, I go over important things that you need to know, you need to watch those videos first. I'll link them in the description box below. Then once you've watched those videos, come back to this one to practice with us. So these questions come from exam papers, and I will be going over all of this and explaining how we mark in an exam. Remember, I'm a teacher. I set exams, I mark exams, I moderate exams. I know where students go wrong and where they lose marks. So you don't want to miss any of my teacher tips that I give throughout the entire video. So watch for the whole video to get all those tips. Let's start with a multiple choice question. So it says 1.2. The diagram below is used to demonstrate the differences between interatomic bonds, chemical bonds, and intermolecular forces. Right. So very, very important difference that we need to make here is the difference, or we need to distinguish between this, the dotted line, which represents one type of force, and this solid line, which represents another type of force. One of them is called an intermolecular force, and the other one is called an interatomic or intramolecular force. So they say, which of the following statements is correct? And they give us A, B, C, and D. We have to choose which one is correct. This is multiple choice. It's worth 2 marks. So which one is correct? X is stronger than Y. X, that is called an intermolecular force. Inter means between molecules. And intermolecular forces are always weaker than interatomic forces or intramolecular forces. So A is wrong. X is an interatomic bond. No, it's not. Y is an interatomic bond. Remember, inter means between. So interatomic means between atoms. And X is not between atoms within the same molecule. Y is between atoms of the same molecule. So B is incorrect. X is an intermolecular force. That is correct. And then they say Y is an intermolecular force. No, it is an interatomic force or an intramolecular force. Those would be the 2 acceptable answers for Y. This question says, what is the type of intermolecular forces present between N2 molecules? Now, you should know that N2, it's diatomic, which means it's a nitrogen bonded to a nitrogen. It's actually a triple bond. Now, if you go back to my Lewis dot diagram videos on multiple bonds, you will see why this is a triple bond. But essentially what this question is asking, it's basically saying if I have 2 nitrogen molecules, so this represents one nitrogen molecule, that's another nitrogen molecule. They are attracted to each other by an intermolecular force. Remember, intermolecular is between molecules. So they want to know what this is, okay? A is not your answer. Triple bonds is not the answer. Triple bonds is a interatomic force. Interatomic because it's between 2 atoms, or intramolecular, inside the molecule. But they don't care about that. They don't care about the bonds. They care about what is between the molecules. So is it dipole-dipole? Is it hydrogen bonds? Or is it London forces? It's one of these 3. These are all intermolecular forces. And the one that best fits this scenario, that suits a nitrogen molecule attracting another nitrogen molecule, is London forces. Induced dipole, induced dipole. The reason why is because nitrogen, N2, is a non-polar molecule. How do you know that it's a non-polar covalent molecule? Because the difference in electronegativity is 0. So it has non-polar covalent bonds. It's a non-polar covalent molecule. And the type of intermolecular forces between a non-polar molecule and a non-polar molecule is London forces. I do have videos that go over in detail how to tell what type of intermolecular force exists between molecules. So again, check out the links below. Right, here is another question, 1.6. It says, consider the substances P, Q, and R. We've got 3 substances, P, Q, and R. And here they tell you very important information. P dissolves in Q, but not in R. And they want to know the most likely intermolecular forces in substance P, Q, and R. What is important to remember before answering this question is that like dissolves in like. It's called the general solubility rule. And what that means is that substances with similar strengths of intermolecular forces will dissolve in others that have the same type of strength. So as you should know, London forces, that's the intermolecular forces that occurs between non-polar molecules. So something that has London forces, that's the weakest type of intermolecular force, will not dissolve in something that has dipole-dipole forces, which is a polar substance. Something that has London forces will also not dissolve in an ionic substance or vice versa. Okay? However, something that has ionic bonds will dissolve in a polar substance. And how I remember it is, for example, an ionic compound like NaCl, table salt, will dissolve in water, which is a polar substance. Water has dipole-dipole forces. So I did make a little summary thing for you that you can just take a look at that may help you. If you are ionic, so for example, NaCl, you will dissolve in a polar substance, which has dipole-dipole forces. Remember, if you watch my video on intermolecular forces, you will know if you see polar, you know it's dipole-dipole forces. Okay. If you are a polar substance and you have dipole-dipole forces, you will dissolve in other polar substances that have dipole-dipole forces. That's where the like dissolves in like comes in. So water will dissolve in alcohol, okay, or vice versa, because they are both polar substances. They both have dipole-dipole forces. However, if you are ionic, like NaCl, sodium chloride, you will not dissolve in non-polar substances that have London forces. They're not like. So ions and dipoles are similar, okay, because they both have positives and negatives, so they dissolve. Polar and polar, they dissolve. Ionic and non-polar, no. Non-polar and non-polar, yes. Non-polar and polar, no. So I hope this summary helps you. So let's take a look at what we think the answer would be for the previous question. So P dissolves in Q, but not in R. Okay, so does ionic, let's start here. Does P dissolve in Q here? Does ionic bonds dissolve in dipole-dipole? Yes. Does London forces dissolve in dipole-dipole? No. So immediately B cannot be our answer. Does dipole-dipole forces dissolve in London? No. Remember, they're not the same. Dipole-dipole, that's between polar molecules. London forces is between non-polar. It's not the same. Ionic bonding, can they dissolve in London forces? No. So actually, we have our answer already. Let's see if it makes sense. So P dissolves in Q, yes, but they're saying P does not dissolve in R. Yes, they don't dissolve. Ionic will not dissolve in London. So our answer is A. Okay, over here we've got a longer question. We've got molecules and their melting points in a table. First thing that you need to know, the stronger the intermolecular forces, the higher the melting point. And now don't get confused. Remember, higher melting point means less negative. So this is the lowest melting point because it's the most negative. This is the highest melting point because it's the least negative, if that makes sense. Think of a number line. So first things first, let's define the term melting point. This is a definition. You need to learn your definitions off by heart and it'll get you 2 marks. So the definition for melting point is the temperature at which the solid and liquid phases of a substance are in equilibrium or are at equilibrium. You have to say the temperature. A lot of my students often say the point at which the solid and liquid phases. It's not a point. Melting point is a temperature. The next question says, explain the trend in melting points in the molecules in the above table by referring to the intermolecular forces and the energy involved. So now what do they mean by trend? They mean that as you go from CH4 to CF4 to CCl4, the melting point increases. And you need to explain why the melting point increases. So I think a very good starting point is to think about what intermolecular forces exist between the molecules of CH4, which is methane. So is it London forces? Is it dipole-dipole forces? Is it hydrogen bonding? Those are the 3 common ones that we will be doing in long questions like this. Then we do it for CF4, then we do it for CCl4. If they have different intermolecular forces, so say for example, one of them had hydrogen bonding and the other one had London forces, that could help us explain the differences in boiling points because London forces are weaker than all the others. So if the one is London forces and the other ones have stronger intermolecular forces, then you'll say, well, London forces are weaker, therefore it needs less energy to overcome the forces. That's why the melting point is lower, for example. But if you take a look at these substances over here, and you have to consider what intermolecular forces they have, you will come to the following conclusion. Now, you don't have to draw these out, but I drew them out to show you. Take a look at all of my compounds. So there's CH4, here is CF4, and here is CCl4. If you had to do the difference in electronegativity for each of these bonds, so the carbon in the fluorine bond, the carbon in the hydrogen bond, and the carbon in the chlorine bond, you would see that the bonds are polar covalent bonds. However, because of the molecular shape, so because this is tetrahedral, the central atom has no lone pairs. Same thing here, same thing here. I hope you guys can see that they all have the same shape. They have the central atom and then the 4 atoms that surround them. And the central atom over here, carbon, 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 has no lone pairs. This is very important. What that means is that they have ideal molecular shapes, which means overall they have a symmetrical charge distribution, which means that they're all nonpolar molecules. Okay, all of them are nonpolar molecules. That one, and that one. They're all nonpolar molecules. And what you should know from my intermolecular forces video is if you are a nonpolar molecule, you have London forces between your molecules. So this one has London forces, that one has London forces, and that one is London forces. So if they all three have London forces, why are their boiling points so very different? Okay, so they all have London forces, so you can't tell me, ma'am, that one has hydrogen bonding, which is stronger. That one has London forces. That's why there's a difference. Your reasoning has to be based on something else. And what you need to base your reasoning on is molecular mass or molar mass. So if you work out the mass of this compound, CH4, then you do CF4, and then you do CCl4, you should see that the molecular mass increases as you go down. Okay, bigger compound, higher molecular mass. And what you should know is the bigger the molecular mass, the bigger the compound, the more surface area you have for intermolecular forces. So higher molecular mass, bigger surface area, more area for intermolecular forces. So although they all have London forces, the biggest one over here, CCl4, can have more London forces. That means if you have more forces, you have stronger intermolecular forces. And if you have stronger intermolecular forces, you need more energy to overcome the forces. And the more energy you need to overcome the forces, the higher your melting point. And that is exactly what you need to say in your answer. So this is exactly how you'll answer it. Always start off by telling me about the intermolecular forces in all of the compounds. So you will say all 3 compounds or molecules have London forces between their molecules. They only have London forces. But tell me what makes the 3 different. What makes the 3 different is that the molecular mass or size increases from CH4 to CCl4. And you could say, man, how do you know that the molecular mass or size increases? If you go to your periodic table and you look at CH4 versus CF4 versus CCl4, and you look at the big numbers on the periodic table, hydrogen has the smallest big number on the periodic table. Fluorine has the second biggest, and chlorine is the heaviest. So if you have to work out the mass for this, so take the big numbers. So you take the big number of carbon, which is 12, plus the big number of hydrogen, which is 1 times 4. You get 16 grams per mole. Then you do that for CF4. Okay, so you get 16 grams per mole. If you do it for CF4, if you do it for CCl4, you'll see that this one has the biggest mass. Anyway, as molecular size or mass increases, that means that the strength of London forces increases as well, okay? Because there's more London forces. That means more energy will be required to overcome the London forces. Therefore, higher melting points. Now, a few things that my students often get wrong that I see when I set papers, when I mark papers, is that they say break the forces. We don't break forces, they're not bonds. We overcome the forces. We weaken the forces. We don't break the forces. Another thing that a lot of my students do is they forget to mention energy. After you tell me which one has more London forces, which one has stronger forces, you need to speak about energy. It's the higher energy that results in a higher melting point. I hope that makes sense. Then my next question, which molecule has the highest vapor pressure at a given temperature? Explain the answer by referring to the data in the table. So what you do need to know is the stronger the intermolecular forces, the higher the boiling point, the higher the melting point, but the weaker or the lower the vapor pressure. Okay, so higher melting point, higher boiling point, lower vapor pressure. And that is always the case. The reason why is because if you have very weak intermolecular forces, it's easy to overcome them, easy to separate those molecules into their gaseous phase, so they will have a high vapor pressure. But if you have very strong intermolecular forces, you need a lot of energy to overcome those intermolecular forces. So it's not so easy to separate them into their gaseous phase, so they have a low vapor pressure. Right, so which one has the highest vapor pressure? It will be the one with the lowest intermolecular forces or the lowest boiling point. So CH4. And that is how you would answer that question. In the next question, they say water, H2O, is a smaller molecule than CCl4, but it has a higher melting point than CCl4. So you should know that water has a melting point at 0 degrees Celsius. Okay? At 0 degrees Celsius, it will turn from its solid phase to liquid phase or vice versa, melting point and freezing point. But why? If we take a look at the table that I gave you, we see that CCl4 over here has a melting point of negative 23. Negative 23, and they say in this question that water is smaller, but it has a higher melting point because remember, 0 is higher, the higher temperature than negative 23. So why is that the case? Well, this doesn't have to do with the mass. Okay, so water might be a smaller molecule, which means it has a smaller area, but what makes water so impressive is that water doesn't just have London forces. Remember, CCl4 just has London forces. You need to know that water has a special type of force that exists between the water molecules. It's a special type of dipole-dipole force called hydrogen bonding. You need to know that. And it's because we have oxygen bonded to hydrogen. So it's called hydrogen bonding. And hydrogen bonding is the strongest intermolecular force. So that is why, even though it's a smaller molecule, it has stronger intermolecular forces because hydrogen bonding is stronger than London forces. So this is how you'll answer the question. You will compare them. And when you compare them, you have to say CCl4 only has London forces, also called induced dipole forces. But H2O has hydrogen bonding and London forces. Hydrogen bonding is stronger than London forces. And remember, if you have stronger intermolecular forces, you need more energy to overcome the intermolecular forces, which means that your melting point and your boiling point will be higher. Last question, write down the name of the intermolecular force that will exist in a mixture of H2O and CCl4. So this is how you do this. H2O is a polar molecule, okay? Which means, and we just mentioned that it has hydrogen bonding, but it's also dipole-dipole, okay? Because polar molecules are dipoles. So dipole-dipole, special type of dipole-dipole though, hydrogen bonding. And CCl4 is non-polar, which means that it has only London forces, okay? But that means, when I say this one only has London forces, I mean if CCl4 is attracted to only CCl4. So if I have a sample of CCl4, within that sample, because it's CCl4 and CCl4, carbon tetrachloride, between those will be London forces, okay? If I have a water sample, so water and water molecule and water molecule, it'll be dipole-dipole forces or hydrogen bonding between those. But because now they're asking between H2O and CCl4, what you do is as follows. This one is a polar molecule, so we think dipole. Okay, if you think polar, you must think dipole. Polar and dipole, those go together. And CCl4, you must think non-polar, and you must think induced dipole. I did make a video on this. But so go check out the links below if you need more explanation. If you think polar, you must think dipole. If you think non-polar, you must think induced dipole. So the force is dipole, induced dipole. Okay, I hope that makes sense. Where does the first dipole come from? It comes from the fact that water is polar, and polar, dipole. Where does this part come from? Induced dipole. Induced dipole is non-polar, and CCl4 is non-polar. Okay, I hope that this has been helpful. If you'd like a part 2, a part 3, a part 4, whatever, let me know in the comments below, and I can't wait to see you in another video very soon. Subscribe for more. Bye, everyone.